Hi, I'm Teacher Thomas. Welcome to A-Level Maths. This is 9231 Further Probability and Statistics, Topic 3, Chi-Squared Tests. Question from June 19, 2021, number 9. A random sample of 50 observations of the continuous random variable x was taken, and the values are summarized in the following table. It is required to test the goodness of fit of the distribution with probability density function f given. And our first requirement, the relevant expected frequencies correct to 2 decimal places are given in the following table. Show how the expected frequency for 1.6 is less than or equal to x is less than 2.4 is obtained. I'll go back to the first slide. Here we have what is referred to in topic 1 as a probability distribution function. To work with probability, we want to change this to a cumulative distribution function. And in order to do that, I want to recognize that the cumulative distribution function, represented by big F of x, is the integral of f of x with respect to x. So I'll integrate. I have the integral of 3 over 16 times 4 minus x to the power of 1/2 with respect to x, which integrates to 3 over 16 times 4 minus x to the power of 1/2 plus 1, 3 over 2, divided by that new exponent, 3 over 2, and also divided by the derivative of the inner function 4 minus x, which is -1, plus c. Simplifying, I get to -1 over 8 times 4 minus x to the power of 3 over 2 plus c. Knowing that looking at my original information, our low end of x is less than or equal to 0, or 0 is less than or equal to x. The low end is 0. So I know that the big F with an input of 0 equals 0. So let's see what that looks like. My output will be 0 when my input, -1 over 8 times 4 minus x, when my input is 0, 4 minus 0 to the power of 3 over 2 plus c. So the left side is 0, the right side has c as a variable, and I can, or let's say a parameter, an unknown parameter, solving for c, I get to the value 1. And with that, I can now complete my cumulative distribution function as 1 minus, that 1 is coming from the c value, the end of plus c, over on the right, I'm now putting that positive 1 in the front, 1 minus 1 over 8 times 4 minus x to the power of 3 over 2. I'll bring this over to the next slide, and we can use this for probability calculations. So we have 1 minus 1/8 times 4 minus x to the power of 3 over 2. We want to show the calculation for 1.6 to 2.4. So I will show, remember this is the cumulative distribution function, so I'm going to show the cumulative probability up to 2.4 by inserting the value of 2.4 into the function for x. And this simplifies to 0.74702. That's cumulative. What I want to know is between 1.6 and 2.4. So I'll find the accumulation up to 1.6. 1 minus 1 over 8 times 4 minus 1.6 to the power of 3 over 2. This is 0.53524. So the range I'm looking for is the difference between these two. 0.74702 minus 0.53524 that provides a probability. Notice up at in the table we're looking for frequencies. So what I need to know is I need to know the probability multiplied by the total events is going to give me my frequency. So let's take a look back at our intro information. 50 observations at the top. So I'm going to multiply by 50, and my result is 10.59, which matches with the expected frequency they have in the table. Continuing to requirement 2, carry out a goodness of fit test at the 5% significance level. So I'm going to work with, first let me see what information, okay, I have my expected frequencies in the second slide. I have my observed frequencies on the first slide. I want to notice whether I need to combine any categories based on expected frequency being less than 5. And notice that this final category, 4.47, is less than 5, which means that I'm going to combine these two categories and analyze them as one. When I combine, the sum of those two gives me 12.65. And for the observations, also I will need to combine, and the sum gives me 8. So notice now I've gone from 5 to 4 categories. Let me set up a table that I can use for completing requirement 2. I have 1, 2, 3, 4 categories. I've been given observed values and expected values. So I'm going to bring those over and then we'll work with them to calculate the chi-squared statistic. These are my values. I'm going to put a small dot next to the 4th category values. Just there a reminder that those are the result of combining the 4th and 5th categories because the expected value of the 5th category was less than 5. Now I want to work with chi-squared is the sum of O minus E, quantity squared, over E. So let's find this value for each of our categories. I'll talk through the first calculation in detail, step by step, and then I'll work through the others and post those to the board. For category 1, I have 18 as an observed, 14.22 as an expected. I'm going to subtract. The value I get I will square, and that result I will divide by the expected value of 14.22. That result is 1.0048. I'm going to go out to 1.005. And for the other categories, the calculation produces next 0.955, 0.633, 1.709. And the result of the summation, 1, 2, 3, 4 values that I'm summing, is 4.302. Now my critical value. I want to know degrees of freedom, which I will start with 4. I have 4 categories. I started with 5, but I've reduced to 4 categories. Minus 1 standard, minus 0, that minus 0 represents 0 estimated parameters. So we end up with 4 minus 1 minus 0 is 3. And we will look up the critical value for chi-squared with degrees of freedom of 3. Notice at the top, 5% significance. We will use 0.95. The result of the lookup is 7.815. I realize now, thinking through what's next, I left out my first step. I did this in the last test video as well. always start with finding the null and the alternative hypothesis. Okay? What's the clue? What if you forgot? How do I realize that I forgot? I realize that I forgot because when I conclude, I need to reference the null hypothesis, and I haven't listed it anywhere. So if you were to forget, once you get to the end, when you need to reference the null hypothesis, that should be your clue. Oh wait, I don't have a null hypothesis. That's what I've just realized, so let me come up with one. The f of x that I have created is a good fit, or not created, I've integrated from the probability distribution function. Okay, so I should say I've derived or calculated. Or big F of x is not a good fit. So now continuing on, after identifying the null and alternative hypotheses, I do the analysis I've completed on the left side of the screen. From there, I'll compare. 4.302 test statistic is less than 7.815. Based on this comparison, I do not reject the null hypothesis. The test statistic is less than the critical value, thus I do not reject the null hypothesis, and I want to describe what that means looking up at my null hypothesis. If I'm not rejecting it, then that's what I describe as my decision situation. F of x is a good fit. This completes the requirements for question 9.